Good evening. The project that I picked is Chapter 11, Building a Dog Pen. Um, Justin's house sits on a lot that's shaped like a trapezoid. He decides to make the back part of the lot usable by building a triangular dog pen for his dog Blackjack. On his lunch break at work, he decides to order the materials but realizes that he forgot to write down the actual dimensions of the area of the lot. He wants to get the pen done this weekend because his buddies are coming over to help him, so he has to order the materials today in order for them to arrive on time. He remembers that one of the sides is 5 feet more than the length of the shortest side, and the longest side is 10 feet more than the shortest side. Can he figure out the dimensions of the triangular pen so that he can order the materials today? So question number 1 is using the diagram of the lot below and the variable x for the length of the shortest side of the dog pen, write an expression for the other two sides of the triangular pen and label them on the diagram. So we're given that the shortest side is going to be represented by x. Then the side that creates the right triangle with the shortest side is 5 plus x. And then the hypotenuse is 10 plus x. So we have x, 5 plus x, and 10 plus x representing the three sides of the triangular lot. Question 2 is, excuse me, using the Pythagorean theorem, substitute the three expressions for the sides of the triangle into the formula and simplify the resulting polynomial. Be sure to move all of the terms to one side of the equation with the other side equal to 0. Remember that the longest side is the hypotenuse in the formula. Make sure your leading term has a positive coefficient and that your squared binomials result in a trinomial. So for this exercise, excuse me, to set up the example for the Pythagorean theorem, a squared plus b squared equals c squared. So we take the sides and we substitute them into the equation. So I have x squared plus x plus 5 squared equals x plus 10 squared. I first take factors of x plus 5 because I need to find factors that are the product of c and the sum of b in the equation. So I factor x plus 5 and x plus 5. I get x squared plus 5x plus 5x plus 25. X squared plus 10x plus 25. Then I factored 10. So x plus 10 and x plus 10. X squared plus 10x plus 10x plus 100. And it equals x squared plus 20x plus 100. Excuse me. So 3, using the equation from problem number 2, factor the resulting quadratic form equation into two linear binomial factors, set each lineal factor equal to 0, and solve for x. So in doing this, there's a long equation. It's x squared plus 10x plus 25 equals x squared plus 20x plus 100. It's the two equations from the above step. Then in this case here, we have to move everything over to one side of the equal sign to get z equals to 0. So I subtract x squared, I subtract 20x, and I subtract 100, and I get x squared minus 10x minus 75 equals 0. I look for two factors. That's product is represents c, and the sum represents b. So I have x squared minus 10x minus 75 equals 0. I factored x minus 15 and x plus 5. So I set x minus 15 equal to 0. I add 15 and I get x equals a positive 15. I set x plus 5 equals 0. I subtract 5 and I get x equals negative 5. The two answers I got are x equals 15 and x can equal negative 5. In this case here, geometric shapes cannot equal negative numbers. Therefore, the negative 5 solution would not apply to this equation. So I went ahead and honored the x plus x equals positive 15. So example A says factor the resulting quadratic equation into two linear binomial factors, and then find the two solutions to the equation from part A using the zero factor law, which I just explained. Question C is, do both of the solutions make sense? And I did explain that only positive numbers could be used. So only one of the numbers, only one of the solutions, 15, is going to make sense in this equation. D is using the solution that makes sense. Substitute the value for x. Determine the dimensions of the dog pen. When substituting the dimensions with the value of 15, I have x equals 15 is the shortest side, x plus 5 equals 20, which is the second longest side, and the third longest side, x plus 10 or 15 plus 10 equals 25. The three sides of the pen are 15 by 20 by 25. And then that would be the dimension of the dog pen. And I have 60 feet is the perimeter. And then question number 4, to fence in the dog pen, Justin plans to purchase chain link fencing at a cost of $1.90 per foot. Example A is how much fencing will he need? And example B is how much will the fencing cost? To figure this out, it's $1.90 a square foot. I did the area. I added the sides. I multiplied the sides, the three sides of the triangle to get the perimeter. And I did $1.90 times 60 feet. And I got the cost would be $114 for the chain link fence. So number 5, how much area will the dog pen have? So the formula for area of a triangle is A equals 1/2 base times height. So I substituted area equals 15, 1/2 times 15 times 20. Area equal, I have 150 equals 300. So the area is 150 feet. And then question number 6 leads into Justin decides to also put a doghouse in the pen to protect Blackjack in bad weather. The doghouse is rectangular in shape and measures 2 by 5 by 3. Once the doghouse is in the pen, how much area will Blackjack have to run in? So for number 6, and I don't know why I didn't label it, but I did the area of a rectangle. So area equals 2L times 2W. So we have sides. The long side of the rectangle is 3 feet. The shortest side is 2.5. So when I do the equation, I get 142.5 feet with the doghouse, because the dog pen is going to take up 150 feet. The the fenced-in area will be 150 feet and 7.5 feet for the rectangle, the doghouse in that area. He'll have 142.5 feet without the doghouse. So question number 7, the sides of the pen form a right triangle, and the measurements of the sides of the pen were found using the Pythagorean theorem. Any 3 positive integers that satisfy this Pythagorean theorem are called a Pythagorean triplet. There are infinite number of these triplets and numerous formulas that can be used to generate them. Do some research on the internet to find one of these formulas and use the formula to generate 3 more sets of Pythagorean triplets, verifying that the Pythagorean triplets are accurate by substituting them into the Pythagorean theorem. So for number 7, I picked the numbers 6, 8, and 10. So I applying that into a squared plus b squared is equals c squared. 6 squared plus 8x squared equals 10 squared. 36 plus 64 equals 100. If I do the math, 36 plus 64 is 100. 100 equals 100, so that does check out. So one of the triplets is 6, 8, and 10. Question number 8. Oh, sorry. Question number 7. The other parts of that is another Pythagorean triplet. I picked 5, 12, and 13. 5 squared plus 12 squared equals 13 squared. 25 plus 144 equals 169. 169 equals 169. That's the second set of Pythagorean triplets that are accurate for the equation. The third set that I picked is 9, 12, and 15. 9 squared plus 12 squared equals 15 squared. 81 plus 144 is 225. 225 is equal to 225. That's the third set for the Pythagorean triplet. And question number 8, which I answered on the paper, is that another way to generate a Pythagorean triplet is to take an existing triplet and multiply each integer by a constant. Take the Pythagorean triplet 3, 4, and 5 and multiply each integer in the triplet by the factors below and verify that the real result is also in Pythagorean triplet by substituting into the Pythagorean theorem. So in this case here, section A gives you a multiply by 3. So I have 9, 12, and 15. If I multiply the given 3, 4, and 5 by 5, I have 15, 20, and 25. And if I multiply by 8, I have 24, 32, and 40. When I apply all of those into the a squared plus b squared equals c squared formula, I do get that the sides are equal. So 9 squared plus 12 squared plus equals 15 squared. 81 plus 144 equals 225. 225 equals 225. That one checks. So 5 squared plus 20 squared equals 25 squared. 25 plus 400. Excuse me. I don't know why I didn't finish this. Equals 25 squared, which is 625. Uh-oh. Let's see. Excuse me. I made a mistake. 400. Oh. Excuse me. So example C is take the sides 3, 4, and 5 and multiply by 8. So I have 24, 32, and 8 times 5 is 40. That one's not adding up. Oh, it's 24. Okay. So 24 times 24 is 576. 20 times 20 equals 400. And 25 times 25 is 625. That one's not working out, so I'm going to have to come back to that. I'm not sure what I did wrong. 8 times 3 is 24. 8 times 4 is 32. And 8 times 5 is 40. 24 times 24 equals 576 plus 2. Oh, that's why. Okay, I apologize. So 24 squared. So 24 times 24 equals 576. 32 times 32 equals 1024. And then 25 times 25. I'm sorry, 40. 40 times 40 equals 1600. If I do 576 plus 1024, I get 1600. So that also checks as the triplet for the Pythagorean theorem. Sorry about that. I wrote a little messy. I couldn't understand it. So that would explain how to apply the Pythagorean theorem to how to build a dog pen. Thanks. Oh,